So tonight I'd just like you to get some more practice with our new logarithms. So what I would like you to do is, for each section, write the 4 problems down, listen through my explanation of the first one in each section, pause the video, try the other 3 on your own, and then go through and check. And you can fast forward to check, and if you got them right, you don't have to listen. If you didn't, go back and listen to my explanation. So this could be a 2-minute video for you if you really understand what's going on. It could be a 15-minute video for you if you need some extra help. It's entirely up to you. So here we go. For our first section, we're going to write each expression, each equation, in exponential form. So number 1, I have this equation. Now remember, we're never going to say log. We're always going to say exponent. So I would read this sentence in one of 2 ways. I could say, the exponent on 2 that gives me 16 is 4. Or you can read it backwards. You could read it as 4 is the exponent on 2 that gives me 16. I tend to like to read it that way, starting with the exponent. So 4 is the exponent on 2, meaning 2 to the 4th, that gives me equals 16. Always read that sentence, never say log. So for number 2, the exponent on 4 that gives me 1 is 0. Or 0 is the exponent on 4 that gives me 1. For number 3, 1 is the exponent on 12 that gives me 12. 1 is the exponent on 12 that gives me 12. And in number 4, negative 1 is the exponent on 1/4 that gives me 4. So negative 1 is the exponent on 1/4 that gives me 4. Okay, so that's going from logarithmic form to exponential form. You also need to be able to work in the other order. So in part 2, I have these 4 problems. Take a minute to write them all down, and we'll talk through them. So when I look at this, I see 5 squared equals 25. But remember, if we're talking about logarithms, we want to think about exponents. So I would start reading this as 2 is the exponent on 5 that gives me 25. Because when I read it that way, then I know to write 2 is the exponent on 5 that gives me 25. It's a nice sentence. That gives me my logarithm. Can do the same thing for number 2. 10 to the negative 1 is 0.1. Or negative 1 is the exponent on 10 that gives me 0.1. Negative 1 is the exponent on 10 that gives me 0.1. Number 3 in this section, 8 to the 2/3 is 4. Or 2/3 is the exponent on 8 that gives me 4. 2/3 is the exponent on 8 that gives me 4. And the last one in this section, 6 to the negative 3rd is 1 over 216. Or better, negative 3 is the exponent on 6 that gives me 1 over 216. Negative 3 is the exponent on 6 that gives me 1 over 216. Okay, in our third section, we're going to evaluate some logs. So notice these are not equations, they're expressions. So we want to read the sentence and figure out what the answer is. So for number 1, I have the exponent on 4 that gives me 64. So in other words, I'm wondering, what is the exponent on 4 that gives me 64? So you could write that as 4 to the x equals 64. What is the exponent on 4 that gives me 64? Well, that is 3. And you really don't want to write x equals. It'd be better to just write 3. You're evaluating. There's no x in that expression. And number 2, what is the exponent on 5 that gives me 0.2? So 5 to what exponent gives me 0.2? People struggle with decimals until they remember that they're really fractions. So 0.2 is read as 2/10. So this is really what's the exponent on 5 that gives me 2/10. That doesn't seem so easy either, but if I reduce 2/10, I get 1/5. So what I'm truly looking for in this problem is the exponent on 5 that gives me 1/5. Well, that is -1. Negative exponent makes a fraction. 5 to the first is 5. So putting it all together, 5 to the -1 is 1/5. Okay, number 3. What is the exponent on 1/5 that gives me 125? So we're wondering 1/5 to what number gives me 125? Well, again, I'm going from a fraction to a whole number, so my exponent must be negative, and 5 to the third is 125. So the answer is -3. And for this last one, what is the exponent on 36 that gives me 6? So 36 to what exponent gives me 6? So here we're going from a bigger number, 36, to a smaller one, 6. And the relationship is that 6 is the square root of 36. This is why you need to continue to know your fraction exponents, and that the exponent of 1/2 means square root. So the exponent on 36 that gives me 6, the exponent on 36 that means square root to give me 6, is 1/2. The last thing I want to remind you of today is graphing logarithms. So if you remember from class, a logarithm is the inverse of an exponent. So there are a couple of ways to do this. This means y is the exponent on 2 that gives me x. So you could write it that way. Y is the exponent on 2 that gives me x. And you could kind of think of a little table backwards. And what I mean by that is y is the exponent, so that's what I would plug into. So if y is 0, 2 to the 0 is 1. If y is 1, 2 to the first is 2. And y is 2, 2 squared is 4, 2 cubed is 8. 2 to the -1 is 1/2, and so on. That might be a quick way to do it. You could also remember that every logarithmic graph has its parent anchor point at 1, 0. And again, that's because it's the inverse of an exponential. This is the inverse. If I read this as 2 to the y equals x, to find its inverse you would switch x and y and get 2 to the x equals y. Well, we know that in y equals 2 to the x, the anchor point is 0, 1. And when we inverse, we switch x and y. So another way you could have done it is to make a table for 2 to the x equals y, or y equals 2 to the x, and then switch all the values, and you would have ended up with this same table. So a couple of different ways to think about log graphs. Also know that their general shape is always something like that. The inverse of an exponential, which is always something like that. So we can plot these points, 1, 0, 2, 1, and I'm just guesstimating here so you get a sense of what it looks like. 4, 2, 8, 3, 1/2, -1. You could do 1/4, -2, and so on. So sometimes people think this looks like square root, and it looks a little bit like square root, but it doesn't end at 0, 0. It continues down. Also remember that x equals 0 is the asymptote for my logarithm graph. There is no way I can get to 0 on my x. It'll get really close, but it'll never get there. Okay, that's it. Have a great night.